Okay, so already we have seen the fluctuation of energy for the turning moment diagram of double acting single cylinder engine. Now here we are going to see the turning moment diagram of 4-stroke internal combustion engine. Okay, now in the 4-stroke combustion engine there are basically the 4 strokes: suction, compression, power and exhaust stroke, and here the each stroke is having 0 to 180 degree. Okay, so 180 multiplied by 4, it is 0 to 720 degrees are there, or we can say it is the 4 pi radians are there. Okay, so since the pressure inside the engine cylinder, here the pressure inside the engine cylinder at the time of suction stroke is less. Okay, so therefore the negative loop is formed over here. Okay, basically in suction stroke there are the two loops. A small negative loop is there and a small positive loop is. Now why it is called small negative and small positive? Because there is a one energy, the turning moment diagram is there, and work done required is this much. Okay, so this much work done is needed to be done by the engine. Okay, and over here from the x-axis, below the x-axis there is a negative loop forms. Okay, now because the work done is needed to done on the gases, so therefore the very small negative loop you can see over here. Okay, and because of the momentum of the piston at the end of the stroke, that is at the end of the suction stroke, because of the momentum of the piston, the energy is released from the piston. The energy is released from the piston, and here you can see a smaller positive loop forms. Okay, the smaller positive loop form. Okay, and whatever the energy you can see over here, okay, which is the blank one. Okay, and that energy is extracted from the flywheel to complete this work done. To complete this work done, that energy is extracted from the flywheel. Similarly, in the compression stroke you can see the higher negative loop is there. Okay, because this negative loop form because the gases, that is work done is needed to done on the gases more. Okay, because in compression the compression of gases is going to be done. Okay, and because of that compression the more work is done, needed to be done on the gases. Okay, so that's why again this total energy is again extracted from the flywheel to carry out that work done. Okay, in the power stroke you can see up to over here the work is done by the engine itself, but there is still the more energy remains, or surplus energy remains, which is supplied to the flywheel, which is stored in the flywheel. The speed of the flywheel is increases. Okay, with the speed of the flywheel is going to be increases in the power stroke. And in the exhaust stroke again you can see the two loops, a small negative loop and small positive loop over here. The negative loop forms because the exhaust gases are there and that needed to expel out from the engine. Okay, so that's why the gases are needed a push, and that energy here it is utilized. Okay, and in the and because of the momentum of that piston, a small positive loop forms. Because of the momentum of the piston, the small positive loop form over here. That is what. So this is what the turning moment diagram of a 4-stroke engine, combustion engine. Okay.